So with that, I think that's all the announcements that I have. I will, again, there'll be an email going out with the link to all of this stuff. I'll probably throw it in the chat as well. But with that, let's go ahead and get started on today's event. So I happened to get connected to Lightspin, gosh, or what's it been, maybe a month or so ago. Super impressed by the technology that they have. They sent me a link to a Kubernetes webinar that Or had done, and I've had so many people that have asked me about Kubernetes training that it just all kind of worked out that we were able to pull this together. So super excited. Or is the co-founder and CTO of Lightspin. Lightspin, for anyone who doesn't know, does security around cloud and Kubernetes, and Or will certainly talk about Lightspin a little bit as well. So, Or, with that, I'm going to pass it over to you. Go ahead and do an introduction of yourself and of Lightspin, and then teach us about Kubernetes.
Sure, amazing. So thanks, Matt. And hi, everyone. It's a pleasure being here and presenting some stuff for training also about Kubernetes. I'll share my screen and then we can get going. Okay, let's see.
All right, good. It's letting you share. That's good.
Yeah. Can you see now the presentation?
Yep. Looks perfect.
Okay, great. So just a bit about Lightspin and myself. And so I'm a co-founder and CTO at Lightspin, a security startup in the domain of cloud security, supporting the cloud service providers and also Kubernetes. And what we're doing is a bit different, putting context into security in cloud today and priority as well, since we know there's a lot of vendors also doing security in this domain. But what Lightspin is so special about is really putting context into our findings and our contextual findings and the risk in your cloud. And a bit about myself. So I've been in the security field for the last 10 years. Started from the blue team side, mostly security engineering and defensive areas. And then I shifted to the offensive side, where I had the opportunity of building a team in terms of research and development of offensive security products. And in the last year, I've been in Lightspin, building a new product in this domain. So that's just a bit about myself. What we do have in Lightspin's website is we do have, as Matt mentioned, 2 webinars I did, which are more advanced in specific topics of Kubernetes. One is more of a workshop for general concepts in security in Kubernetes, which is half, let's say, hands-on and half technical stuff in Kubernetes. And the second one was container-specific security in Kubernetes. So there are 2. Both of them are available in our website. So if you want to go and get more advanced topics in Kubernetes security, so just feel free. It's not there's nothing related to our product over there. It's really more about general information and some concepts in Kubernetes which are not that known to the users. So in this, in our current training, what I'm going to speak about is I'm going about like why Kubernetes, why are people shifting into Kubernetes, what's it in general, and what are the containers in Kubernetes, a bit about Kubernetes. So my general, I would say, approach is that some of you might be totally new into Kubernetes and some of you maybe are more familiar or maybe more advanced. And then I'll just go a bit about, I took 3 concepts I think are important in Kubernetes. I'm not going through all of them because I don't think we would have the time. And then I'll just deep dive more a bit security concepts and the architecture in Kubernetes. If I have time, maybe I'll be able to even deploy one application inside Kubernetes so we can just go through some flow in that area. Please feel free to ask questions regarding what I'm going to show and talk about. So let's just get started. So Kubernetes is what's called the container orchestration system. It was developed by two guys in Google, and then it was donated to the CNCF, and I think it's in production since 2015. I think the last year had a really rapid adoption for Kubernetes in the world. There's a lot of shift towards using Kubernetes. So we're going to speak about this a bit as well. Some general, I would say, concepts in Kubernetes. So all services in Kubernetes are natively load balanced. Scaling is one of the core concepts in Kubernetes. So scaling up and down happens dynamically, and I will show a bit of examples of how we are used to scale our applications, outside of Kubernetes in the old maybe world, or maybe in on-premise, and also in cloud where we're using infrastructure only, and how is it done in Kubernetes. And there's also a lot of capabilities regarding self-healing and the entire orchestration that wraps our applications in the cloud. So why are people shifting, or companies and teams are shifting to Kubernetes? So first, it provides us with a really great runtime environment for our Docker containers. The scaling is very simple, and I'm going to show how it is done. It's sort of abstract our infrastructure for our containers, and sometimes for people it seems like Kubernetes is another infrastructure on top of our current infrastructure. It's sort of an entire ecosystem that lives within our infrastructure. The monitor and the health check are existing for Kubernetes, so the self-healing can happen quite easily. And there's basically a definition for how we run the containers. I'll show some example for this, not super technical, but some definitions that are easily to understand. So when speaking in Kubernetes and trying to even compare this into what we know, or like the infrastructure as services we know it today. So we have our cloud infrastructure, and then we have our Kubernetes, which is, as I mentioned, sort of an entire ecosystem for running our applications on top of the cloud. Some of them might have duplicate, I would say, components, like we have our load balancers in the cloud and also load balancers inside Kubernetes. We have our hosts or nodes, which are the same, running our workloads. Database can live in both areas, and also other services like secret management and so on. So sometimes it can be a dedicated or a very standalone ecosystem on our cloud or on the on-premise, and sometimes there's a lot of mesh and connections between them, whether it's databases, load balancers, network traffic, and so on, and even identity and access management. There is a new, I wouldn't say approach, but a new types of Kubernetes deployments from recent years, where the cloud service providers are allowing us to have managed Kubernetes deployments, where actually the cloud service provider is responsible or deploys or sort of wraps the entire deployment for us, which is building the entire infrastructure for Kubernetes, but also manages the control plane for Kubernetes. In AWS, for example, we're not accessible for the management of the control plane. We have interactions with the API. We're able to control the entire infrastructure, but we don't have access to the processes running our control plane. So there's pros and cons for this, some related to security, some related to other issues. There's also other pros where we get auto scale for the nodes themselves, where we manage this by ourselves. We have to do some of those jobs manually. And also in terms of network connectivity, we do get lots of benefits from using managed Kubernetes, where there's also controllers for the external load balancers running in our Kubernetes environment that automatically can be notified of new applications and can be configured dynamically. So there's a lot of, as I've said, pros and cons. There's a lot of times, in new deployments, one of the biggest considerations when shifting to Kubernetes is starting with on deployment using tools like COPS or using managed Kubernetes solutions that all cloud service providers have today. So I'll start from the beginning. Maybe from some of you that will be quite familiar, maybe for some of you not. So a container, as we know that's our a lightweight and portable application for us. That's how we wrap, and that's the minimal way for us to wrap our application today. That's the most common one. In terms of the security, there's a lot of debates. Is it more secure or not? It gives us a lot of benefits in that area, where we can run lots of containers on one host and still having the kernel sort of shared between them and achieving really minimal applications. If I try to compare this to virtual machines, so if on the virtual machine side, we'd have to deploy a virtual machine every time we want a new application. In containers, we don't need to do this. We can run multiple containers from different applications on the same host. So it's quite agnostic. And we don't have to really have our own guest operating system deployed from zero for every application. We gain lots of efficiency, but I think we lost a bit in security in those terms. And the way container works is that we define on a Docker file how our container is defined and what's the application, how it runs, what are the prerequisite steps needs to be before we can run our application. And then we have our client that builds our application inside a Docker image, and then running those on one of our hosts, where the image usually is stored inside a registry and then pulled into the host while running the container or while getting the latest image. So let's just try and see how it works inside Kubernetes. So in Kubernetes, the pod is sort of an abstraction that represents our application inside Kubernetes. Usually it has one or more containers inside a pod. So a pod can have one container inside, but it also can have multiple containers inside a pod and also multiple volumes inside that pod as well. For example, my pod can include my WordPress application, my MySQL database, and the storage or the volume that keeps my data in stateful way. Pods are sort of an atomic unit inside Kubernetes platforms, and they are created once they are deployed inside Kubernetes. So that's just the most common object we're using today in Kubernetes. Pod always runs on a node, and a node is the host running, whether it's physical or virtual host, running our applications in Kubernetes. So in those cases, we can see that a node actually runs multiple pods, which each one contains its own containers, where on each host we would have to, or node, we need at least the Docker engine or any other engine to run our containers, and the kubelet agent, which is our local agent that allows us to control and communicate with the Kubernetes, let's say, control plane or API. Okay, I'll go over some concepts in Kubernetes. I've chosen only 3 for this training. Some that I think are very important and usually used in the beginning of the journey in Kubernetes. The first one is the replication or the replica set, as it's called in Kubernetes. Usually, before running with Kubernetes or any orchestration platform, when we have our application and we want to have a scale and replicate our application, so the normal steps that we know are deploying a new application server, then configuring our application inside that server, and then usually we add our new application to our load balancer on its configured pool with its health checks. And some of those steps can be automated, but still those are manually steps that we're doing, or automated steps, but in order to scale our application or replicate it in the way we used to know. In Kubernetes, it's done differently. And on the left side, we can see a definition for application in Kubernetes. So it's a YAML file. If for some of you it's too technical, so there's basically not so much low-level information here. The thing that we are looking at right now, and it's important to understand, that's the replicas. So if I would say that my front-end application, the number of the replicas should be 3, then automatically I would have 3 instances or 3 pods for this application running with load balancer managing the traffic dynamically. If I would like to scale my application and add more, so all I have to do is edit this deployment and just change the number from 3 into 4 or 5. That will notify my replica set controller to automatically scale my application and notify the load balancer for my new application IPs, and that happens dynamically. So small step, but huge difference for us in terms of replicating or scaling our applications inside Kubernetes. Of course, some of those are also can happen, I would say, automatically, but those are more advanced, I think, topics, and I'm not going into them right now. The second concept I choose to spoke with is about the daemon set. So the daemon set usually ensures that can ensure, if we were using daemon set, that all of the nodes in the cluster, which are our virtual host or physical hosts, are running a copy of a specific pod. Where we see this kind of use case is basically if we want to have a monitoring for our entire infrastructure and hosts. So we just declare that we're using a daemon set, and then on every new host in the cluster or new node, we would have automatically a deployment for the pod that does the monitoring. And this is just an example with Datadog, but it's also valid for network monitoring, logs collection, storage monitoring, everything that needs to monitor or analyze and have interaction with the underlying infrastructure. So that's usually when we're using daemon set. The third one would be the cron job. The cron jobs are scheduled tasks that run inside our cluster. They ran periodically based on a schedule that we defined. And just like having a scheduled task that does backups or anything like this, it's really easy to define this, really easy to use, and it's like sort of out of the box, and one of the controllers existing in Kubernetes that allows us to really enjoy or benefit from the orchestration layer and the rich orchestration layer in Kubernetes. I think most of the common use cases are backup our databases or stuff like this. It does require a minimal image to do this. So everything here relies on a container to run what we want to run here. So that's also part of the things that we should be aware of. A basic deployment for Kubernetes usually consists of a master node, where the master node holds the control plane, which is the API server, the controllers, the other controllers, whether we have a cloud controller manager, usually in a managed Kubernetes deployment. Also the scheduler and the etcd stores are usually secrets and other data. Then we have also the nodes which are running our workloads, so the containers running on them, which are part of the pods. We have the kube proxy and the kubelet, which is the agent we also use to communicate between the nodes and the control plane. So that's usually how a basic deployment for Kubernetes is. Our users, I would say in this case, the admins usually interact from the outside with the kube API server. That's usually how it's done. If the pods inside our clusters needs to communicate also with the API server, so usually they are using a different concept called service account. I would speak about the authentication and the authorization layer a bit later, but then the communication is done through the components inside the nodes into the API server, and it's done in a different way with service accounts. I'll speak a bit about Kubernetes security. So one of the considerations, I think it shouldn't be sort of a consideration, because the best practice is always to have our API server in Kubernetes private one. And one of the examples here is that we can see latest CVs found for Kubernetes API servers or Kubernetes at all. So one of the things you should be considered, and I think as far as I've tried some of the latest managed Kubernetes deployments, in some of them the API was public by default. So it's something you should be aware of and notice when you're deploying your Kubernetes clusters. Of course, if those are private ones, then there should be a different way of interacting with the API server in Kubernetes. So I've mentioned earlier the authentication layer. So we have two, I would say, entity types for authenticating against Kubernetes. So we have just the normal users, and then we have the service accounts. The normal users are used for management of the cluster, interacting with the control plane. And the service accounts are used for the pods or the applications themselves when they need to interact with the cluster, with the control plane. Sometimes we see sort of an abuse for this when service accounts are created for external management. But the basic idea in this case is that we would have service accounts for internal applications and pods, and normal users for the external management in Kubernetes. Of course, the authentication can be federated outside to the cloud service providers, usually if we use a managed Kubernetes deployment. So for example, our AWS user or role can be authenticated against also the Kubernetes cluster. Kubernetes doesn't have an object that represents the normal users. They can be added through any API call, but the user are represented through a valid certificate that usually is signed by the CA in the cluster. So once we sign a new certificate in the cluster for a specific user, that basically allows us to authenticate against the API server to interact with the cluster. So that's the way it's done if it's not federated, as I've mentioned, usually to the cloud service provider or any maybe other authentication mechanism. In contrast to this, the service accounts are sorry. Yeah, so the service accounts are also managed by Kubernetes. They can be declared and created through the API servers. And usually they are bound to a specific namespace and relates to certain pods. So they can be used for the application to authenticate against the cluster, cluster API. The authorization mechanism in Kubernetes is done using a role-based access control. So usually we have the roles that we create inside the cluster and the cluster roles also created in the cluster. And they have the entire definitions of what any entity can perform in the cluster. I will show some examples for this. And they use a specific API endpoint inside Kubernetes to drive the entire authorization decision. Let's see, an example for this one. So as I've mentioned, we have roles, we have cluster roles, and then we have the bindings for each. The difference between roles and cluster roles is that role is also bound to a dedicated namespaces, and a namespace in Kubernetes is sort of like a virtual or logical, I would say, I don't know, an entity or sort of a zone where we have certain applications living. It's part of segmenting applications from each other inside Kubernetes. So any rules and permissions that we would have inside the role definition would be relevant only to the namespace it is related to, whereas cluster role has an impact and effect on the entire cluster. So if our application has a bind to a cluster role, it means any permission defined in the cluster role is relevant for the entire cluster. So let's see a diagram for how it looks. So we have our role or the cluster role inside the cluster, and then when we have our subject, which can be the service account or the user in this case, and it has a binding to a role, then it lives only in the namespace scope. Even if we have a role binding to a cluster role, which can be also done, it's relevant only to the namespace itself. But if we have a cluster role that binds us, a cluster role binding that binds us to a cluster role, then the scope is for the entire cluster. So it's something very important to notice. It's not very, I would say, at least from our side, we see this abused by many, I would say, vendors or partners inside the Kubernetes ecosystem that by default define themselves cluster role. Although the Kubernetes ecosystem is very rich with lots of vendors from all the areas, from storage vendors to network and lots of solutions, it is important to notice that most of them are using cluster role with very high permissions. So if it's not necessary, I would just try to make sure the access to their application is not allowed by default. So it won't have the cluster role permissions can be exposed. Just to summarize that Kubernetes role-based access control, inside the cluster role or the role, what important here is that our binding has the users, groups, or service accounts that has the ability to use those permissions, and the permissions are usually defined as verbs, whether I can get, list, update, or delete anything. And then the resources on what I'm able to do this. For example, I can list all the pods in the cluster. I can get all the pods in the cluster. I can list all the secrets or all the daemon sets in the cluster, or even update or modify, an existing definition. one of the, I think, cool things inside Kubernetes is also that you can run commands inside your container through the API endpoint. So it really allows you to interact inside the container through the API. And it's a very nice way of doing this by setting specific permissions. Another concept in Kubernetes would be the network policies. Network policies are quite like firewall rules as we know them, or security groups, if I try to give it a similar definition like we know. It controls the entire flow of the traffic that goes inside any pods or outside of the pods. So we have ingress rules or egress rules from the cluster. And they are also namespace specific. So if I have a network policy that allows my WordPress application to communicate with my MySQL, and it is related only to the WordPress namespace, then the meaning is that this rule is relevant only for this namespace and for this application. Another component, and I would say also sort of a concept that we have in Kubernetes, is a built-in secrets management mechanism. So usually a secret in generally, so in Kubernetes is when we have an object that contains one of our sensitive informations, whether it's passwords, tokens, keys, that our application usually is using. The secrets can be mounted by default as a data volume for our application. So we would see this like a file in our file system, but also as an environment variables for our container to use inside the pod. And it's also very easy for our application to interact with. One of the things that I would say about secrets also is, and this is, I think it's a bit of an advanced topic, and also one of the two workshops and the two webinars I've mentioned earlier. The first one is really dedicated into secrets management in Kubernetes, is that both the service accounts and the users that we create inside Kubernetes, which has tokens and passwords, and both our application secrets, which can be the database username and password, or the token, I don't know, to Salesforce or any other service, all of them are stored in the same place. So if I'll just go back a bit to what we've spoken before about role-based access control. So if I have an application that has a cluster role with list all secrets in the cluster, it means it can see both the application secrets and the users and the admin's secrets or the service accounts. This is an issue not so known, but this is important for us to know because lots of applications are and third-party solutions we are deploying inside Kubernetes by default use the list secret or list everything in the cluster. And then when one of those are compromised, then the compromised pod or application usually have access to even the admin secret. If I try to explain it in other use cases, so imagine that your load balancer in your on-premise environment has the ability to get all of your users' passwords from the Active Directory. So that's just trying to demonstrate what's the impact of this. And I'm not just saying this so I would scare you and say I don't use Kubernetes. So I think the otherwise is important. Use Kubernetes. I think it's a wonderful platform. Yes, when you scale a lot, it gets complex, but it does have some security issues from its built-in architecture, which haven't been resolved yet. So just a summary for the security concepts I've spoken about. So we've been through the authentication and authorization mechanism, a bit about the network policies and how we enforce network traffic, and a bit about storing secrets and using secrets in Kubernetes clusters. I'll do a just deep dive inside the way Kubernetes is built from the architecture side. So we have our control plane here above, where it usually is, those are processes or containers running on the master node. If we're using managed Kubernetes, then this area is not something we have access to or can manage. We can only interact with the manager, with the master in Kubernetes. So that's where we manage our Kubernetes clusters. We also have our data plane, which is the nodes running our pods applications. And then our external users for our systems or for our platform usually interact through the kube proxy to our pods or the load balancers. And the interaction between the internal components to the API server is done through the kubelet engine I've just mentioned. So that's just a high level of how Kubernetes is built. Usually here in the master, all the controllers are running, and the entire master components, the API server, the controllers, the etcd, and the scheduler are running inside a known and specific namespace called kube system. So if you would see by default a lot of pods running inside kube system, some of them called system controllers, etcd, DNS. So those are the pods that are related to the control plane. And then we have all our applications usually deployed within the default namespace or other namespace we define by ourselves. So I'll give just a bit summary about what we've spoken, and then I'll have maybe a few minutes to just deploy one application inside Kubernetes cluster. I've set locally on my virtual machine. I've mentioned earlier that Kubernetes gains rapid adoption latest years. Usually in the last year, I think, there's a lot of shifts towards Kubernetes. We spoke a bit about containers and how they are running inside Kubernetes. I just spoke about three concepts, which was the replication, the daemon set, and the cron job that allows us to really use the rich controllers and orchestration layer in Kubernetes. I've been through some of the security concepts in Kubernetes and what controls we have in place in Kubernetes. As of today, of course, they can be, we can have more inside the cluster. And a bit about the architecture. So that's basically what we've spoken about. If you have any questions, so feel free before I'll just go and try to demonstrate just deploying one application inside a cluster, running locally on my PC.
Yeah, or I've got a couple of questions. So you had mentioned that Kubernetes is gaining rapid adoption or is just growing in popularity. So I think our audience has got, there are some organizations that are maybe using some Kubernetes and then some others that haven't, but maybe they are looking at doing it. Can you talk a little bit about maybe benefits of using Kubernetes? Which parts of organizations, is this more of a development platform? Is it more of a production platform? And can you talk about that stuff a little bit?
Sure. At least from what we see today, lots of companies running Kubernetes for the entire ecosystem. Is it for dev, test environments, even production? We have lots of customers running Kubernetes. Their entire production runs on Kubernetes. Usually, I think the initial the initial thoughts on maybe shifting to Kubernetes starts from the R&D. That's usually, I haven't seen cases, where the security owners or the infrastructure, and architects, maybe architects, but are trying to push towards Kubernetes. Starting with Kubernetes, I would say, I wouldn't say it's too hard. Usually, if you're using a managed Kubernetes by the cloud service providers, but once you get high scale and you want to really use the rich benefits that Kubernetes allows you to use, it gets complicated. It is really complicated. And there's a lot of security issues inside Kubernetes. I think, although Kubernetes exists from 2015, most clusters that I have seen are not running without security tools and without security controls in place. And usually I think that the DevOps are the ones holding the keys, or the gatekeepers to Kubernetes. They are the ones in charge on the deployment, usually the infrastructure. In some companies, there's SREs, the site reliability engineering, managing those. But I think DevOps today are a key personnel that are really in need in order to use Kubernetes to manage this correctly. So there's a lot of importance for those in Kubernetes as well.
So you had mentioned a couple of times now, you've talked about there's some security issues in it. So is that too much permission granted to, or too much access, or what's just, again, like for people that are starting out in the Kubernetes world, what's one security thing you would tell people to really be on the lookout for?
So I think, the three maybe things you should be aware of is, first, don't open your Kubernetes API to publicly. We've seen many cases where it's open publicly and runs sometimes with anonymous access. I know that if you're deploying Kubernetes as a managed Kubernetes, usually it really has authentication in place. But if you're using self Kubernetes deployments, so I think some of them by default allows anonymous access to the API server. So if you have deploying this publicly with the anonymous access, then sometimes we see lots of security issues in that area. So this is one thing in terms of the deployment, of how the deployment is managed. The second thing is really using, I would recommend using tools that gives some network visibility, like service mesh tools. I haven't mentioned them yet, like Istio and Calico and WeaveNet. So you get a sense of who's speaking with who in the cluster, and like what's running on the cluster, get some visibility in those. So before starting putting controls in place, security controls, I would start with getting some visibility and understand like what's happening inside my cluster. And I think there's a lot of, and yeah, you mentioned the permissions. So if I try and compare this to identity and access management or role-based access control from cloud service providers, so it's not that mature in Kubernetes. For example, you can't put deny policies. You can't say like this user cannot do this. You can only say what it has, what's allowed. So you can't put minimal permissions for lots of cases. So the role-based access control is not that easy to use. So those are the key, I think, things when starting with Kubernetes you should be aware of.
So I guess anyone that's anyone that's out there that is using them, it seems to me, because I'm getting the feeling that a lot of times Kubernetes is started from a development team, some sort of a DevOps team, and maybe or maybe not, the security team has visibility into there. Sounds like there could be some pretty big vulnerabilities there as far as APIs and access being wide open. So if you are using it, probably good to get a handle on it. All right, great stuff. I think you're going to show us how to launch one of these, so I'll stop talking.
Okay, great. No, it's fine. Okay, so let me just okay. So can you see my virtual machine? Try to put in
Yes.
Great. So one of the easiest way to start with Kubernetes and just get a hands dirty inside. So there's a deployment method called Minikube, which usually it runs the entire Kubernetes as a one process on your virtual machine. It can be your Linux, Mac, Windows, whatever you want. It's really deployed easily, and then you get a sense of the entire Kubernetes on your local machine. So I've just like pulled the download, and I'll just try to start my Minikube cluster. So it's like running a cluster inside one process locally. Let's see. Oh, so I need a Docker for this. I will just run this within a few seconds, and then I'm going to deploy from one of our open source. We have a Redcube, which is doing sort of an assessment for, there's a cheat sheet that allows you to run different commands on Kubernetes to get sort of a security assessments for your cluster. It's based on MITRE attack tactics and techniques. And I just have a deployment here from one of our labs that we've done with a to-do list application. So it's really small one. So I'll just try and show this, hopefully. Okay. Okay, let me see. I guess I need some driver here. Let me just pick this one. Okay. Okay, maybe it's this one. Yeah, just install the driver. Okay, I don't know why it's not running. Let me see if I think I have a different cluster already in place.
Always the fun of doing something live.
Yeah, yeah. Okay, so luckily I have my demo cluster running in AWS. Okay, so I've deployed lots of applications here on my cluster. You can see when I'm running get nodes. So by default, I'm getting applications or pods running in the default namespace. If I would like to get kubectl, that's the command line tool that we're using in Kubernetes to communicate with the API. So if I would like to get pods for all the namespaces, see what I have in my cluster. So just running get pods for all the namespaces, then I'm getting the default pods running inside my cluster. I have Istio also installed. I've mentioned earlier that the controllers are running inside the kube system. So you can see them running inside here. And also some other dedicated applications I have deployed earlier. And I think I have here locally, yes. So I have here, let's say my application. Usually we describe this in a YAML file. Okay, so this YAML file describes an application. One application I'm going to deploy. It's called a deployment YAML. What I'm doing here basically is that I'm deploying an application with one container. The container is called to-do list. It's from a repository for logic, and I'm getting the latest version of this. So this usually would deploy, and I've shown earlier about the replica. So currently it would deploy one instance of my application, one pod. So to deploy this, all I have to do is run kubectl apply -f to the to-do list app. And you would see that the resources are created inside my cluster. Now running the kubectl get pods again. would show me that my to-do list is already running. Okay. If I would like to expose my application for, let's say, for my load balancer or for the outside world, then I would have to, for example, in this case, I would just expose my application. This case, I would say to the Kubernetes cluster, instead of installing a load balancer and then exposing those, with lots of configurations, as we know with load balancer, look at my deployment called the to-do list deployment and expose my my to-do list app as a to-do list service and expose this on the node port, meaning on their node that runs my application. So this would cause my service to be exposed. And if I'll try to this would show that my to-do list application is exposed on this cluster IP. That's the external port here, and that's the internal port for the pod. I haven't connected this to any external IP, so I can't access this remotely. I tried to do this. That's what I thought I was doing with the Minikube, but so yeah, that's what I've shown here. So that's a basic deployment for Kubernetes. On Kubernetes website, there's a lot of tutorials. One of them, I think it's for the WordPress, which is a very common one. Sorry. Deployment, it's on their website. I really recommend if you want to try using this one. So it has lots of concept using inside, also some storage and the database and some secrets using. So this is really a good one to start with. Yeah.
Well, maybe you can send me that link, and we can put that in or throw it in the chat or something as well.
Sure. Yes.
So we're kind of getting up close to the hour here. Anyone have any questions? I think for me this was a lot of new stuff, so pretty heavy stuff here, technical stuff, right? So I think this was awesome.
I didn't really have a question. My little statement that I put in there was one of the things I've seen coming up more recent than not is the conversation around, like, when you look at manufacturing and production, right? And I think the Phoenix project hits home on it really well, like what DevOps does if you look at it from a one-piece flow standpoint, but then doing your micro-segmentation, the idea of taking your manufacturing line, breaking it down into all the micro-segmentation so that now you really do have one-piece flow and can change things. It really is similar to that production, but just like manufacturing plants push back to their headquarters on security and things that slow down manufacturing, I'm seeing more and more of that in conversations from the DevOps side. Like, hey, we're trying to do DevOps because of the speed at which it allows us to do things. So the conversation with those security teams is almost like those same conversations you're seeing with the plants. And a lot of times those DevOps teams are completely separate. So I think there's going to be a much bigger conversation around that, right? Because the security tools, or you might be able to talk to this too, like the idea of people that play really well with Linux tend to play very well with Kubernetes and cloud workloads and so forth. So, when people say they have a small Linux environment today, yeah, take a look at what your DevOps environment's going to look like in the future and really think about that, because you're thinking too narrow-minded, and DevOps becomes part of your business. So slowing down the business, reinforcing the business, helping the business, those are the conversations I think that everyone needs to start hitting home to all their CIOs and everybody else's around those lines.
Yeah, it's different than just some Linux servers that you've had running a website or internal site or something out there for a while, for sure. So,
yeah.
Or when you talked about some of the security issues around Kubernetes, right? That's what Lightspin is all about, right? Is getting some visibility and putting some of that security around your Kubernetes environment. Yeah,
exactly. So since we've seen really rapid adoption in those Kubernetes security tools that exist, before Lightspin even, what we're trying to do different is, since there's a lot of connections between your cloud infrastructure layer and your Kubernetes environment. So you can't just use one solution for your cloud and one solution for your Kubernetes. You have to have both in the same place. So what Lightspin does is really taking everything that inside Kubernetes, all the data, collecting this and putting them with context to allow you really to understand the problems. Like your applications have access to all your secrets. You have your tokens in clear text and all over the place where your developers are really unaware of. You have pods with lots of vulnerabilities exposed using your AWS load balancers, and you're really not aware of those issues. And even your control planes are sometimes exposed in a way you haven't seen and you're not familiar with. So Lightspin is about covering all of those and putting the context in of those and prioritize the work. And the findings that we have in the detection and the resolution also for Kubernetes. That's basically it.
Yeah. So, I mean, if any of you that are out there, if your organization is using Kubernetes and you are trying to get a handle on how to secure it, I've seen a demo and had conversations with Lightspin. The interface is really, really nice. The technology is excellent. So I definitely recommend taking a look at what Lightspin is doing. It's lightspin.io, right, is the website. So awesome. Great stuff. Thank you so much. Everyone from Lightspin, thank you for putting this on for us. We've had lots of people asking for stuff like this, so I'm super excited that we could bring it to everybody, and I appreciate you guys doing it. Everyone else that's out there, I did put a link for the 25th event in. We'll also send out an email. But again, thanks everybody for attending. We're going to get $300 off to Kids Food Basket. So that's $300 worth of meals for kids that otherwise wouldn't have anything to eat. So I appreciate everyone supporting us in that regard as well. And Or, nice to see you. And thanks again. And we'll talk to everybody later. Thank you.
Thank you very much, Matt. Thanks.
Yep.
Bye.
See you, everybody.